So on question 5 on the exam, they want you to show a scatter plot. So when you show a scatter plot, it's just years for the X and contribution for the Y. And you're just going to pick an appropriate label with 1, 2, 3, 1, 2, 3, 4, 5, blah, blah, blah. And maybe go by, I don't know, hundreds on this one, 100, 200, 300, 400. And you're just literally going to plot the points, 1 and 500, 5 and 100.
Right, that I can do manually.
Yeah. 3 and 300.
That takes us back to chapter 2 in the book.
Yeah. And
making
so,
graphs and stuff. That I can do without using a calculator.
Yeah. So yeah, definitely don't need a calculator for this part. And you're going to need to show them anyway, so we just plot it by hand.
Yeah.
We get something. We see that our data kind of follows a line a little bit, right? And we're going to use our R value to figure out how closely it does match that line. So our calculator is going to do everything for us. So what we're going to do is we're going to take out our calculators, we're going to plug this whole thing into list 1, that whole thing into list 2. So it's stat and edit, clear out list 1 by hitting clear and enter, and put the 1, the 5, the 3, the 10, the 7, and the 6 in list 1, and in list 2, 500, 100, 300, 50, 75, and 80. So we got that. And then we're going to do, our calculator's going to do everything. We're going to hit stat, and then scroll on, oh, I can do this. We're going to hit stat, we're going to scroll on over to tests, we're going to scroll up to linreg t-test, it's letter E there, linreg t-test. Everything should be set fine, my data's in list 1 and list 2, frequency is 1, we don't care about that or that, so we're just going to scroll on down to calculate, hit enter, and it tells us absolutely everything we could possibly want. For question 5, all he wants is the R value, which they tell us is negative 0.88. And the closer it is to 1 or negative 1, the better our...
this is the E-link you said, right?
The E-linreg t-test, there's no K in there, yeah. In linear regression t-test.
And then calculate that.
And so... closer this value is to a 1 or negative 1, the closer our data fit this line. But how close is close? We do a hypothesis test. For these problems here, where you're testing the correlation, your null hypothesis is always that rho equals 0, and your null hypothesis is always that rho doesn't equal 0. The null would mean that there is no correlation. And this one would mean that there's a correlation. So to get your critical values, you're looking at a special table in the back of the book. So in your book, it is... okay, it's table I on page 793.
I got it marked as chapter 10 on there. You see that? The graph they use for chapter 10.
Yeah, nice. Page 793. And so your degrees of freedom is always your sample size minus 2. It even says it on the chart. So we have 1, 2, 3, 4, 5, 6. 6 minus 2 is 4 for our degrees of freedom. Our alpha, I think, was a 0.05. And so here, 4.05, we get 0.811. So 0.811, and it's negative because ours was negative. And so we look to see, now we can make our normal conclusions. Our guy falls over here, negative 0.88, just barely. And so, reject the null or fail to reject the null?
Reject or fail.
Reject that null, right?
Yeah.
It's in that rejection region.
Okay.
You can think of those tails as the rejection region. Falls in that rejection region, you are rejecting the null. So if you are rejecting the null, this is bad. There's a correlation there.
There's enough
Totally a correlation.
sufficient
Sufficient evidence to support that there's a correlation. Awesome. So now that there is a correlation, you could use the same data to answer his questions for number 6. In question 6, he talks about finding the equation of the regression line and finding the prediction equation. And so your calculator, from what you just wrote, so for question 6, your calculator, everything you just got, it has at the very top, it says y equals a plus bx. And if you scroll down, it'll tell you what a and b are. So in this case, a was 453.2, and b was negative, so I'm just going to do negative 50.4x. And this is your prediction equation,
Ah,
right? And that's what this line should be, the line of best fit. So if you were to make a line, draw the equation of a line that goes through there, it should have a y-intercept of about 453.2 and have a slope of negative 50.4.
So what's question 6?
The questions will say find the equation of the regression line. Yeah?
Okay.
Yeah. And which is the same thing as the prediction equation.
let me.
Yeah.
The .0811. That and
yeah.
Where's that? That's on the graph. That's the
That
number gives
was
you on the
our-
graph
That was our critical value from the table.
from the table.
Mhm.
Okay, so that's now we're at the negative .88, so it's in the tail area.
Mm-hmm. So
Thank
we
you.
rejected that null. Awesome. And so now that we have a prediction equation, we can predict whatever the heck we want. Like, let's say we wanted to know what the contribution was after 2 years, right? So you could say if x was 2, then y would equal 453.2 minus 50.4 times 2. And this would give you some lovely answer. And that would give you the second part. Now, does that make sense?
You have to multiply what with 2 again? I'm sorry.
So you would plug in 2 for the x.
Okay.
so
and
the way
that's
it looked-
because of
So the way it looked on here is like use that to find specific values when x is 40 or when x is 15.
Okay.
So you want to find the y values at certain x values. So just plug it into the equation that you got.
Where'd you get the 2 for the x?
I made it up. So this is I
Hypothetical.
hypothetical, yeah.
So this is it going to be like this on for number 15? Is that what it's going to look like for number 6? If you know what I mean. Like that's how
Yeah.
they're going to set it up, and then you're just going to have to put it in the calculator
Yeah.
and then do that after.
Yeah, because I think the way I was showing you before was with the equation, because I thought he wanted you to write out the equation.
Yeah.
But it sounds like he's going to be okay with you using the calculator. Just make sure you make a note. I would write it exactly like this, like use the calculator to find,
Yeah.
use graphic calculator to find this.
This
this,
thing
and
shows
that.
you every friggin'
It
thing.
does, yeah.
It shows you what the problem is. Y equals a plus bx. The hypothesis is when it equals 0. The null hypothesis is when it doesn't equal 0.
So the
This is sweet. And I was struggling with that scientific calculator. No wonder I was getting lost.
Yeah, you can't use the baby calculator. You can almost get away with the scientific, but you can't use a graphing. I mean, you can't use anything less.
So we put the A in the calculator, so it's 4.532, and then for
So all I'm going to do for this part here is
Okay.
evaluate it at a certain point. So I'm going to do the
Nice.
453.2 minus the 50.4, and then in this case I just did times the 2. I made up this part. He's going to ask you use the equation to predict the value when x is a certain number. And then you just plug it in. It looks a little bit like that, like that. And you're at 352.
So let me ask you this, Laura.
Yeah.
Once we get all that information, we can get rid of this and go back to just doing the
Yeah.
the equation then.
Mm-hmm.
So I will hit what? Clear this.